Question 11. What is brazing paste? Answer. Brazing paste is a material consisting of metal alloy in a powder form mixed with a binder. When it is required, brazing flux is added to the brazing paste to provide protection from oxidization. Question 12. In what applications is using paste feasible? Answer. Paste can be used for torch, induction, and furnace applications. In these applications, flux is usually added to paste formulation. When using paste in a vacuum or atmosphere furnace, flux does not need to be added to the paste. Question 13. What is the shelf life of brazing paste? Answer. Brazing paste that is in its original unopened container is warranted for 90 days. Similarly to the flux, this warranty does not mean that after the 90 days the paste will not function. Functionality can only be determined by melting the paste to see if flows or not. If the alloy flows, then it is still functional. Conversely, if the alloy balls up, then it is not functional. Question 14. What is the proper clearance for brazing? Answer. In general, a joint clearance ranging from 0.002 inches minus 0.005 will produce sound high-strength joints when flux brazing. When atmosphere and vacuum brazing, joint clearance should be 0.000 minus 0.002. Care does need to be taken when brazing metals with different coefficients of thermal expansion. The amount the materials expand needs to be factored in when determining joint clearance. Question 15. What types of joint configurations can be used when brazing? Answer. There are several different types of joints that can be used. The most common of these are butt joints, lap joints, and butt lap joints. Pictures and calculations for determining the length of a lap joint can be seen by mouse clicking here to go to the Principles of Joint Design article. Question 16. At what temperature should the furnace be at when furnace brazing? Answer. Typically the furnace will be heated to a temperature 50 Fahrenheit minus 100 Fahrenheit above the liquidus of the filler metal being used. Question 17. What is the strength of a brazed joint? Answer. The strength of a brazed joint depends on several different factors, these being the base metals being joined, joint clearance, filler metal used. Joint strength varies with use of different base metals and filler metals. Joint strength also depends on the gap between the two metals being joined. When the gap is increased, the joint strength decreases. Oftentimes, under the correct conditions, the brazed joint strength will be equal to or greater than the strength of the base metals. For more in-depth information on the types of brazed joints, see our article on brazing joint design. Question 18. What is Handy 1? Answer. Handy 1 is a flux cord product that simplifies the brazing process. Handy 1 is a brazing alloy in strip form rolled around a measured amount of powdered flux. As the part is heated, the flux is released, providing protection from oxidation. It is available in multiple filler metals and flux combinations to join virtually all common metals. Question 19. What alloy is recommended for brazing copper to copper? Answer. In most cases, when brazing copper to copper in air conditioning and refrigeration service, one of our SiLFOS alloys would be recommended. The phosphorus in the alloys allow the SiLFOS group to be self-fluxing when brazing copper to copper, which eliminates the use of a separate flux. Question 20. Can stainless steel be brazed in vacuum below a temperature of 1700 Fahrenheit? Answer. Stainless cannot be vacuum brazed in at a temperature below 1700 Fahrenheit because of the possibility of chrome oxide formation, which will prohibit the flow of the filler metal alloy on the stainless steel. A brazing temperature of at least 1750 Fahrenheit is usually recommended in vacuum for stainless steel. If the stainless steel is nickel plated, it can be brazed at temperatures lower than 1700 Fahrenheit. Question 21. What braze alloy would be appropriate for brazing 300 series steel that will be subjected to contact with water? Answer. When brazing stainless steels that will be exposed to water, an alloy should be used that contains nickel. Examples of these would be Easy Floor 3, Braze 505, Braze 630 and Braze 403. The nickel in these alloys helps prohibit interface corrosion within the steel. To learn more about interface corrosion, please read Technical Bulletin No. 9 or contact Lucas Miyop Technical Service.